Hi, I'm Ken Black. Welcome to Business Statistics for Contemporary Decision Making. Today we're going to study when to use what technique in estimating parameters and testing hypotheses. Probably by now in this course, you're either in the second semester or the second half of the semester, and you will begin to be confronted with various techniques that we use to construct confidence intervals or test hypotheses. And one of the real daunting tasks for you will be to sort out the various techniques, to begin to understand the big picture, and to be able to see the forest for the trees. To assist you in pulling this together and helping you to see the big picture and to see how the various techniques fit in the big picture, we want to learn how to construct a tree diagram that pulls the various techniques together. Before we do this, however, I want to share with you a few questions that we ask when we're sorting out the various techniques. One of the basic questions that we want to ask, the very first question probably, is are we estimating or are we conducting a hypothesis test? When we're estimating, we're usually constructing confidence intervals. Once we've determined if we are estimating or testing hypotheses, another question that we might ask is, how many samples are we using in our analysis? Of course, the number of samples that we take is driven by how many parameters we're testing. Commonly, we take one sample or two samples or three or more samples. Another question that we might want to ask is, what parameter are we testing or estimating? And there are many parameters that you can test or estimate. In this particular course, there are mainly three. There is the mean, the proportion, and then there is the variance. So we want to ask ourselves the question when we're trying to determine what technique to use. Are we studying the mean, the proportion, or the variance? If we know that we are estimating means or conducting hypothesis tests about means, then there are two other questions that we might want to ask. One question is the population standard deviation or sigma known, or is sigma unknown? And then a fifth question is, if we're analyzing means or conducting tests about means, what is the level of data of the values that we are using to conduct the analysis? Using these questions, we can now construct a decision tree to help formulate a big picture of how and when to use what statistical techniques. So let's begin by learning how to construct a decision tree to determine what statistical inferential technique to use. Our very first decision would be, are we estimating or are we conducting a test? In fact, the chapters in the books are organized along these lines until later in the course when we mix them to some extent. When you're estimating, you are actually constructing a confidence interval. And of course, when you're testing, you're conducting a hypothesis test. It's absolutely critical that we determine which of these we're doing. Now let's examine the branch of the tree diagram that deals with confidence intervals or estimation. If we're constructing confidence intervals, in this particular course, our first decision is, are we using one sample or are we using two samples? As soon as you determine how many samples you are taking, our next decision point is, what parameter are you estimating? Are you estimating the mean, the proportion, or the variance? If you're estimating a mean from a single sample, then you have another decision. And that decision is sigma known or is sigma unknown? Looking at these particular branches on the tree, we can see that if you're conducting a confidence interval estimation with one sample and you're estimating a population mean and sigma is known, you're going to use a z-test. And in our textbook, this particular technique is presented in section A1. If you are estimating a mean from a single sample and sigma is unknown, we're going to use the t-statistic, and it's located in section A2 of our text. If you're estimating a population proportion from a single sample, then you will use the z-test or z-statistic in section 8.3. If you're estimating a population variance from one sample, then you will use the chi-square statistic, and this information is presented in section 8.4 of chapter 8. On this side of the decision tree, we are taking two samples because we want to estimate the difference in two population means or proportions. So, we have as branches of this particular part of the tree, means and proportions. If we're estimating the difference in two population means, we have some other decisions to make. For example, are the samples independent or are they dependent? Independent samples or dependent samples? If the samples are independent, we have one more decision that we have to make, and that is are the variances known or are the variances unknown? So now let's go back and use our decision tree to help us determine which technique to use. If we have two samples in our estimation and we're using sample means and they are independent and the variances are known, we're going to be able to use the z-statistic. And these techniques are presented in section 10.1 of the book. If the variances are unknown from independent samples and we're estimating the differences in two population means, we will use the t-statistic, and this technique is presented in section 10.2. If we're using two samples to estimate the difference in means, but we have dependent samples, then we have a different statistic that we use. It also is a t-statistic, and it is presented in section 10.3. If we're estimating the difference in two population proportions using two samples, then we will use the z-statistic, and these materials are presented in the text in section 10.4. To summarize, in constructing a decision tree to help us determine what statistical technique to use, we can ask ourselves 5 questions. The first question is, are we estimating, thereby constructing a confidence interval, or are we testing, thereby conducting a hypothesis test? The second question is, how many samples are we taking? The number of samples you take is driven by how many population parameters you're estimating or testing. Commonly, in this course, we study using 1 sample, 2 samples, or 3 or more samples. And another critical question that we ask ourselves in constructing this tree is, are we estimating or testing a mean, a proportion, or a variance? And if we are estimating means or conducting hypothesis tests about means, then we need to ask 2 more questions. The first question is sigma known, which usually results in a z-statistic, or is sigma unknown, in which case we use the sample standard deviation and we probably will be doing a t-statistic. And the other question, if we're estimating means or testing means, is what level of data do we have?